All right, today we're going to look at 1D motion equations and how I get between position, velocity, and acceleration. We're also going to do a little bit with displacement. So here I have a little graphic to help you with. So in order to get from position to velocity, I have to take a derivative. To get from velocity to acceleration, I take a derivative. To go back the other direction, to go from acceleration to velocity, I have to take an integral with respect to time. Velocity to position, I have to take an integral with respect to time. So I'm going to show you how to do that here. So I have a velocity function. It's 8 plus 5t minus 2t squared. X is going to be in meters with time in seconds. So now to get a velocity function, I will take the derivative. You notice when we take a derivative that anything that is a constant, like the 8 I have here, goes away. And I'm just left with 5 minus 4t, where this is in meters per second with t in seconds. Okay. Notice I've lost some information. So whenever we take a derivative, so this is my derivative of x with respect to time, I lose that constant, if there is a constant. Okay. Take the derivative again, I get an acceleration function. In this case, I get negative 4 meters per second squared, and that is the derivative of my velocity function, or the second derivative of my position function. Okay. So I have my acceleration. So what if I want to go backwards? What if I want to start an acceleration function and I want to get back to this function? Now notice we did lose some information. So we need this information. We need to figure out what is that 5 and that 8. How do we get those back? So when we take our integral, so the velocity is going to be the integral of negative 4 dt, there has to be some initial condition given to us, or a condition of that fact. So you might see something like starts at rest, or you might see something like the initial velocity is 5 meters per second. Okay, so let's say that's ours. They're telling me that the initial velocity is 5 meters per second. Or I guess you could say the velocity at time 0 is 5 meters per second. So I take my integral and I end up with negative 4t plus c. Now, instead of using c here, because this is a velocity function, this c value is my initial velocity. And so whenever you get to taking integrals with velocity and position, the c is just our initial value for it. And so sometimes they just call it the initial condition. So they did tell me v naught was 5, so I do know here that this is going to be negative 4t plus 5. Okay. So I want to find position, so I'm going to have to take the integral again. So I'm going to take the integral of 5 minus 4t dt. Now, the initial condition they gave me in this case is x is equal to 10 at time 2 seconds. Okay. So x is equal to 10 meters. Oops. We'll see if that works. I don't remember. So x is equal to, so I get 5t minus, all right, so I'm going to take the integral. So this becomes 2t squared. So we're on par so far. We just need this plus x naught value. Okay. So we're going to go ahead and plug 2 in here. Okay. So I have 2 is equal to 10. So 10 is equal to 5 times 2 minus 2 times 2 squared plus x naught. Looks like my 10s cancel. I got my negative 8. Move it over the other side. So x naught equals 8. Perfect. So now I know what this is, and so I can say that this is now 8 plus 5t minus 2t squared, where this is in meters with t in seconds. And so yes, that was the same as we started with. So we need some sort of condition in order to go backwards, in order to go from acceleration, velocity, velocity, position. We need some conditions, and those will help us with those constants that we might have lost in our derivatives from earlier. Now I want to look at this displacement. Now in order to find displacement, there is no conditions needed. I can get to displacement from a velocity function without any conditions, and I want to show you why that is. So I start with a velocity function. So in my case, we're just going to use this velocity function over here. So I have a velocity function of negative 4t plus 5. And I want to take the integral from, say, 0 to 2 seconds. Okay. So I do this, and I go, all right, I can do this. So I take my integral, and I get negative 2t squared plus 5t plus x naught. Okay? So there's plus this c value on here. And now I'm going to evaluate it from 0 to 2. Now you don't have to do the plus c, but I'm going to show you why you don't have to. Okay? So here I'm finding my displacement. And so now I do final minus initial. And so this is essentially saying what's your final position minus your initial position. That's why this is displacement. So I have my position function. So I have negative 2 times 2 squared plus 5 times 2 plus x naught minus it evaluated at 0. So 0 plus x naught. Notice I have x naught minus x naught. That's why I don't need conditions when I do definite integrals. And so here you get your displacement is negative 8 plus 10. My displacement is 2 meters. Okay. Remember to be careful. It's not just asking you when it says displacement, find the position at 2 seconds. It's asking you to find the displacement. So you can either use the definite integral from your time 1 to your time 2 of your velocity function, or go the old-fashioned way and say the displacement is x evaluated at 2 minus x evaluated at 0. And you should get the same result.